When dealing with a 400 amp meter feeding two 200 amp main breaker panels, the question arises about sizing the grounding electrode conductor, or GEC, according to NEC section 250.66. Specifically, the discussion revolves around whether to add the size of each 3/0 copper conductor together to determine the proper GEC size, or to use a single 3/0 copper conductor as the reference size, given that these conductors are not considered to be in parallel. Note 1 to section 250.66 clarifies this situation. According to Note 1 to 250.66, it is necessary to add the sizes of each 3/0 copper conductor together to determine the proper GEC size. This requirement stems from the fact that the conductors are not running in parallel. When conductors are not in parallel, the GEC must be sized to accommodate the total ampacity supplied by those conductors. In the scenario presented, each 3/0 copper conductor has a certain ampacity rating. To determine the overall ampacity the GEC must handle, one must sum the ampacity of each individual conductor. The ampacity of a 3/0 copper conductor is generally considered to be 200 amps in typical installations, but it is best to verify the specific ampacity from NEC table 310.16. based on the conductor's insulation type and termination temperature rating, as well as the ambient temperature. For example, if each 3/0 copper conductor is rated for 200 amps, then the total ampacity would be 400 amps. This total ampacity is then used to determine the appropriate size of the GEC based on NEC table 250.66. In this specific case, if we assume that each 3/0 copper conductor has an ampacity of 200 amps, then the total ampacity being supplied is 2 times 200 amps, which equals 400 amps. Referring to NEC table 250.66 for a service entrance conductor size of 400 amps, a copper GEC of 1/0 is usually sufficient. Now let us increase the conductor ampacity to 300 amps. That would require our 4/0 copper conductor. To reiterate, because the conductors are not in parallel, you must consider the aggregate ampacity when sizing the GEC. If the conductors were in parallel, the rules for sizing the GEC would be different, as you would then be dealing with the combined ampacity of the parallel conductors, but that's not the case here. The important takeaway is that Note 1 to 250.66 specifically addresses situations where multiple conductors feed separate panels from a common service, and it mandates that you account for the total ampacity when selecting the appropriate GEC size. This ensures that the grounding system is adequate to handle any fault currents and maintain safety within the electrical system. To summarize the process, firstly, determine the ampacity of each individual conductor feeding the separate panels. This information can typically be found in NEC table 310.16, or the conductors are already rated for 200 amps or 300 amps. Secondly, add together the ampacities of all the conductors. Thirdly, using the total ampacity calculated, refer to NEC table 250.66 to determine the appropriate size of the copper GEC required. This table provides the minimum GEC size based on the size of the service entrance conductors. Fourthly, ensure that the selected GEC meets all other requirements outlined in NEC Article 250, including proper termination and protection from physical damage. It is important to remember that the NEC provides minimum requirements, and it may be necessary to upsize the GEC in certain situations to meet specific engineering or design considerations. In addition to the GEC, it is also important to ensure that the grounding electrode system itself is properly installed and maintained. This system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes, that are bonded together to form a low impedance path to ground. The grounding electrode system is essential for providing a safe and effective path for fault currents to flow back to the source, thereby minimizing the risk of electrical shock and equipment damage. When installing or modifying an electrical system, always consult with a qualified electrical contractor or engineer to ensure compliance with all applicable codes and standards. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. In the specific scenario of a 400 amp meter feeding two 200 amp main breaker panels, if each of the 3/0 copper conductors feeding the panels has an ampacity of 200 amps, the combined ampacity is 400 amps. According to NEC Table 250.66, a service of 400 amps requires a copper GEC of at least 1/0 copper. However, if each 3/0 copper conductor has an ampacity of 300 amps, the combined ampacity is 600 amps. In this case, NEC Table 250.66 would require a 4/0 copper GEC. It is crucial to always refer to the latest edition of the NEC and consult with a qualified professional to ensure that the grounding system is properly sized and installed. The NEC is updated regularly to reflect new technologies and best practices, and it is important to stay informed of the latest changes. Proper grounding is essential for electrical safety and equipment protection. By following the requirements of the NEC and consulting with qualified professionals, you can help to ensure that your electrical system is safe and reliable. Remember that this explanation is based on the information provided and should not be considered a substitute for professional electrical advice. Always consult with a licensed electrician or electrical engineer for specific guidance on your electrical system. It is also worth noting that the size of the grounding electrode conductor, or GEC, is not necessarily the same as the size of the equipment grounding conductor, or EGC. The GEC connects the service equipment to the grounding electrode system, while the EGC provides a path for fault current to flow back to the source from equipment and appliances. The EGC is sized according to NEC Table 250.122, which is based on the rating of the overcurrent protective device protecting the circuit. It is important to understand the difference between these two types of grounding conductors and to size them correctly according to the NEC. In addition to sizing the GEC correctly, it is also important to ensure that it is properly installed. The GEC should be run in a straight line as much as possible and should be securely fastened to the building structure. It should also be protected from physical damage. The GEC should be terminated to the grounding electrode system using approved methods such as exothermic welding or listed connectors. Proper installation of the GEC is essential for ensuring that the grounding system is effective in providing a safe path for fault current to flow back to the source. Furthermore, the grounding electrode system itself should be inspected regularly to ensure that it is in good condition. Ground rods should be checked for corrosion and damage, and ground clamps should be tightened to ensure a good connection. The resistance of the grounding electrode system should also be tested periodically to ensure that it is within acceptable limits. A high resistance grounding electrode system may not be effective in providing a safe path for fault current to flow back to the source. Regular inspection and maintenance of the grounding electrode system are essential for ensuring that it remains effective in protecting people and equipment from electrical hazards. When working with electrical systems, it is always important to follow safe work practices. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. De-energize circuits before working on them whenever possible. Use lockout/tagout procedures to prevent circuits from being accidentally re-energized. Work with a qualified electrician or electrical engineer whenever possible. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. In summary, when sizing the GEC for a 400 amp meter feeding two 200 amp main breaker panels, you must add the ampacity of each conductor together to determine the total ampacity that the GEC must be able to handle. Refer to NEC Table 250.66 to determine the appropriate size of the GEC based on the total ampacity. Ensure that the GEC is properly installed and maintained. Follow safe work practices when working with electrical systems. By following these guidelines, you can help to ensure that your electrical system is safe and reliable. This information is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a licensed electrician or electrical engineer for specific guidance on your electrical system. Finally, remember to consider any local amendments or requirements that may be in place. Local jurisdictions may have additional requirements that go beyond the NEC, and it is important to be aware of these requirements to ensure compliance. Always check with your local building department or electrical inspector for specific information on local requirements. Electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest changes. Attend continuing education courses, read industry publications, and participate in professional organizations to stay informed of the latest developments in the electrical field. By staying informed and following best practices, you can help to ensure that your electrical work is safe, reliable, and compliant with all applicable codes and standards. Remember, safety is always the top priority when working with electricity. Take your time, follow the rules, and consult with qualified professionals when needed.